Good afternoon, flippers. This is video 3.7. Unit title is Rooftop Triangles. The objective is I can use CPCTC to prove that parts of two triangles are congruent. And you see the Excel skills, there are none. So please work on the ones that you've been working on. They are due on Wednesday. All right, let's go, flippers. So far we've been working on these triangle congruency theorems. And I want you to understand that triangle congruency theorems, the ones you studied so far, there have been 4 of them, okay? And you've been able to use them to prove that two triangles are congruent. Well, once you have proved two triangles are congruent, you have the power to now use CPCTC, and that stands for corresponding parts of congruent triangles are congruent. You see the CPCTC? Again, corresponding parts of congruent triangles are congruent. So, if we look at this diagram, where we see triangle ABC is congruent to triangle XYZ. So here's ABC is congruent to XYZ. So that order really matters. So what we can do now, because these two triangles are congruent, is list their corresponding parts. And if we list the corresponding parts of these two triangles, we list the corresponding angles and the corresponding sides. So let's actually do that. So if we look at the first triangle, triangle ABC and XYZ, remember, the order matters. This is where labeling is going to help us. Now, by just looking at triangle ABC is congruent to triangle XYZ, we should be able to label the angles that are congruent. So let's label them. Angle A, because it comes first, is congruent to angle X. Angle B is congruent to angle Y. Use 2 for that. And then angle C is congruent to angle Z. 2, 3, 1, 2, 3. Let's write those at the bottom. There we have it. Angle X is congruent to angle X. Angle B is congruent to angle Y. And angle C is congruent to angle Z. So let's do the sides now. The sides should be pretty simple because basically the two angles, right, if we think about it, the side that will be congruent will be sandwiched in between the two angles. So if we look at angle X, which is congruent to angle A, and we look at angle B, which is congruent to angle Y, side AB is going to be congruent to side XY. So we can actually mark those. AB is congruent to XY. And if we want to confirm the next two sides that are congruent, we can clearly actually look at the wording that's given in the original congruency statement. So triangle AB, so that segment AB, is congruent to segment XY. And we can clearly see we've already marked that one. And if we keep going in that order, we'd get segment BC is congruent to segment YZ. So here's BC. Let's give it 2 marks. And here is YZ. Give it 2 marks. And let's write that statement as well. We have our next statement. Segment BC is congruent to segment YZ. And finally, the last statement should be very simple. Okay? Again, if we look at order, because again, order matters. If we go from the angle that has 3 markings, which is C, to angle A, that will be from 3 to 1. So that would mean segment CA is going to be congruent to segment over here, 3 to 1. We're looking for 3. Well, there's 3 angle Z, 1 angle X. So this is going to be segment ZX. And there we have all of our congruency statements. Now, we know that we could use the symmetric property to flip these around. And what I mean by that is we could say, well, angle X is congruent to angle A, and angle Y is congruent to angle B. Or we could have segment XY is congruent to segment AB, using, again, the symmetric property. But these basic congruency statements are statements that can be made after we have written a statement like this that shows that two triangles are congruent. And you will notice that on your proofs that you have especially your quiz take home that is due Wednesday, that you have a couple of them that ask you, well, how do you prove that a side is congruent? How do you prove that an angle is congruent? This is what you will need to prove it. CPCTC. Now we're ready to look at an example. An example that says, given the problem that we just looked at, it says, which statement must be true? Is angle C congruent to angle Y? Well, we know that's not true, because we just proved what angle C is congruent to. Is angle A congruent to angle X? Well, it looks like one of our corresponding part statements. So we're going to actually circle that one. But we're going to verify the other ones too. Side AC, well, we know side AC, even if we switch it around, would not be congruent to YZ. And side CB is not congruent to XC. So there we have it. Statement 2 is correct. So here's our first example. And it says, the diagram below shows a pair of congruent triangles. Angle ADB is congruent to angle CDB. And angle ABD congruent to angle CBD. So let's just make sure that we can see those in the picture. So we've got ADB. If we look, that's right here. And that's congruent to CDB. It's marked. We see those with markings. And then we got ABD congruent to CBD. Okay? And then we obviously should be able to now go ahead and mark off the corresponding sides. So before we do that, let's actually write a statement about the two triangles that is true. Okay? A statement, and it says that triangle BDA is congruent to triangle BDC. You probably wonder, how can I write that statement? Well, I'm using angle, side, angle. We can see that these two triangles share this side because of their reflexive property. Here's the angles that are congruent. Here's another pair of angles that's congruent. So angle, side, angle makes it true. So I wrote my congruency statement based on side, this angle, this side, and this angle. So I went B to D to A and B to D to C. So now that I have the statement, I can write corresponding parts statements for angles and for sides. So let's do that. So here we have all the statements that are going to be true. All the angle statements, well, two of the angle statements are already given, so I didn't just write those again. But here's the third one, which says that angle DAB, and here it is, 3 markings there, is congruent to angle DCB. And from that, I was able to go ahead and make my congruency statements, my corresponding statements with the sides. They are congruent statements, but they are corresponding part statements. So I can mark off BD, which is congruent to itself, and we know that. And then because the AD is congruent to CD segments, these two segments, and then segments AB and segments BC are congruent. And then we want to look at the question, okay? In the question, clearly we can see right away that the one that is true we have on our screen is going to be this bottom one. Segment AD is congruent to segment CD. Example number 2, it says, if triangle ABC is congruent to JKL, which is congruent to RST, then BC must be congruent to, well, first thing you need to do is draw these 3 triangles. Triangles, now you want to label them. Label them, remember, order matters. ABC, JKL, RST, because they're all congruent. Here we have these 3 triangles, and I kind of think of this as transitive property, right? If this is congruent to this, and this is congruent to that, then this must be congruent to that, right? So they're looking for BC. So if we find BC in our triangle, which is here, we're trying to find out which side is congruent to any other triangles. Well, that's clear to see here. If we look at BC, it is here, and in the other corresponding triangles that are congruent, the corresponding part would be KL and ST. Again, KL and ST. So if we look here, the only option is ST, so let us mark it. So here is your secret hot question. It says, in triangle JKL, which is congruent to triangle MNO. Which statement is always true? 1, 2, 3, or 4. Please make sure you draw this picture first. Draw it. Then list all the corresponding parts using CPCTC. List all the parts. And then pick which answer makes sense. Okay, and remember, the Excel skills that you're working on are due on Wednesday, so please get them done.